Alright, what's kind of weird? What did I ask you guys to find? What did I ask you guys to find? The remainder. Okay, this is a little weird. X minus 3 goes into 2x cubed minus 3x squared plus minus 10x plus 3. Class, how many times is x going into 2x cubed?
2x squared.
Multiply. Subtract. Negative 3 minus negative 6.
3x squared.
X goes into 3x squared.
3x.
Multiply. Negative 10 minus negative 9.
Negative x.
X goes into negative x.
Negative 1.
Remember, anything minus itself is equal to 0. So what's our remainder, class?
0.
0. Raise your hand if you got 0. Okay. How do we go from x minus 3 to this number?
You put plus 3.
You set it equal to 0.
You get plus 3.
Add 3 to both sides, you get x equals 3. So when I put the 3 here,
Positive.
it is positive. And then we just write our coefficients. 2, negative 3, negative 10, and 3. Okay, what do I do first?
Bring down the 2.
Now what?
Multiply 2 by 3. 6.
What math operation?
Add.
What do you get?
3.
Multiply. Add.
Negative 1. Multiply. Negative 3. 0.
Oh, look at this. I also got a remainder of 0. Huh. That's cool. Alright, remainder theorem. So we started off with this binomial, x minus 3. We're asking, is it a factor? It can be divisible, but this is how I got the 3 there, right? So what we're going to do is we're going to actually take that value, x equals 3, and we're going to put it into the function. Take 3, put it into the function. Plug and chug. So basically, every x value, we're putting in 3. Multiply our exponents. We're going to do our exponents first. So 3 cubed. And 27 times 2. 3 squared. Times negative 3. Negative 10 times 3 plus 3. 54 minus 27 is 27. 27 minus 3 is negative 3. Negative 3 plus 3 is?
0.
Oh, look at that. 0 again. Alright, so I didn't give you a formula. Didn't really tell you how to do it. Remainder theorem says if you just take the x value of your binomial, you set it equal to 0, and if you just plug it in, substitute it and evaluate it, you actually get the same remainder. Everyone say yay.
Yay.
Now, what are some advantages of doing this? Your best friend. Your best friend. Then I can go to table, second graph, and we put in x equals 3. The answer is 0. Is that nice? I can actually check my answer. I don't have to do a different form. Okay. Gets better. Gets better. This is your output. Yes?
Yep.
Output, is it x or y? So we're basically saying at 3, 0, I don't know, the graph's going to look something like this. And what we're trying to say is that it does cross the x-axis. So in today's lesson, we have the remainder theorem. And the remainder theorem helps us answer this question. Is it a factor? Well, you just have to look at the remainder. If the remainder is equal to 0, then the answer is yes, it's a factor. Or if the remainder is not equal to 0, then what's the opposite of this? No, not a factor. Question, what's the remainder? 0. So it is a factor. It is going to cross. What do we need this for? Because eventually I'm going to tell you to get this super huge polynomial, and I'll tell you factor it, graph it. And you're like, Mr. A, I can graph polynomials. I can look at the end behavior, right? But you may not know where to start. So in tomorrow's lesson, we'll learn about the rational roots theorem, but we use the remainder theorem and factor theorem to figure out if this is a factor. Is this a starting point? Is this an answer? And that can help us get other ones. But the big idea is you can find the remainder using the remainder theorem or any of these other methods, and this will help us figure out, is it a factor? In this case, it is.